All right, welcome back again, everybody. So, as promised, as the multiplication video is uploading, I am talking now about long division. Now, long division, obviously, um, is something that always seems to worry a lot of people. It's something that always kind of is like a big no-no. And sometimes it can be something that really can be, difficult, especially when we are dividing numbers that just don't have a nice even, like just a nice end point. So if I said like I had 100, oh no, hang on. Oh no, egads. Oh, here we go. So like, let's say if I had 100 chocolate eggs and I divided that amongst 10 of my friends, one of the more basic long division problems ever. I have 10 chocolate eggs, right? So, oh, another fun method just because I like doing these things. You notice how there's two zeros and 1 0? If you just cross out 1 0 each, it turns into 10 divided by 1, and you get 10 again. Okay, I'm sorry. That was just a quick fun part. But anyway, so basically division is I have a number of something and I'm pretty much breaking it down to equal groups. I know sometimes when I talk to students or anybody else, sometimes even having something more visual, like drawing out, you know, 10 boxes, and well, you get the point. Drawing 10 boxes and then, oh, I'm sorry, here, putting like, I don't know, 10 dots in each box, you know what I'm saying? So, sometimes doing like that visual method can help out as well. Um, but sometimes doing the visual drawing route will take a little bit longer. Um, and again, the more we practice our skills, our math facts, the more that we can use that to our advantage. Now, it does get a little trickier though when we're talking about multiple digit numbers here and long division. I showed you one of the most common, one of the most well-known um, dividing the 3 and 2 digit number there. But, what if we have something as oddly strange as 240 divided by 12? Once again, I'm using grid paper because grid paper helps us in the end. Um, Grid paper is something that is useful, and again, the visual sense of our lining up our numbers correctly and making sure we do what we gotta do. Now, before I even tackle this 2-digit and this 3-digit, let's make our lives a little easier and let's just get rid of that 1 for right now. And actually, let me redraw that 2 because that's not as good. Let's see, a little bit better. Okay, a little bit better. If I just had this, okay, in a long division style problem, we always start with our number here, and we're actually breaking it down. We always start with the first number to the left. Now, I know it's weird because when we do multiplication, we always, we start here and work our way over, but it's different now with long division. We take our number, our divisor out here, and we're basically now starting from the most left. And when we do this, we have to ask ourselves, can 2 go into, 2 in this case? And it can. 2 goes into 2 once. If I did 2 divided by 2, I would get 1. 2 goes into 2 once. And now this is when it gets a little complicated. Now we basically have to do multiplication in the end too. You take this number, multiply it by that. 2 times 1 is 2. And then we do subtraction. 2 minus 2 gives me 0. Now you're like, Mr. W, why? I'll explain in the end, I promise. Bring down my next digit. It's actually going to go there. So most of the time, numbers like these will not always perfectly go into each other. And we will have another example after we divide this number by 12. Okay, so you can keep this as 0, 4, or just be like, okay, I bring this number down, next number down, and it's 4. We now have to ask ourselves, 2, how many times can 2 go into 4? Well, 2, 4, oh, twice. So if I'm counting off by that, it goes in there twice. 2 times 2 is 4. 4 minus 4 is 0. Bring down my last digit, 0. 2 goes into 0, well, 0 times. I don't know. It can't go in there. So 2 times 0 gives me 0. 0 minus 0 is 0 in the end. Okay? Oh, I put that there. So, in long division, we have to ask ourselves, how many times can this number go into, and then this number, this number? We then have to multiply, right? We have to multiply this to get to here. We then have to subtract it in order to figure out, do I have anything remaining in there? In a perfect long division problem, you want it to start getting out to zeros because that makes your life a little easier. And in the very end, once you get to your final number here to the most right and you end up with 0 in the end, this ends up being your final answer. If, for reasons, there is a number down in the very end, you call those the remainder. That's a remainder number. So, like if I had, so anything down there, again, would be your remainder. And in this case, it's 0, so you don't even have to say there's a remainder of 0. It's fine. But if it was 1, 2, 3, 4, 5, anything like that, you would then put like 0 remainder 1 or remainder 2, something like that. But again, once you want it to make sure it gets to 0, if it's possible. That's always the most perfect ideal solution. But it's not always that way. And I'm actually going to show you one example. All right. We're just going to erase all that. Okay. All right. Here we go, here we go. Here we go. All righty. Perfect. All right. So as promised, we're going to do that 12 divided by 240 again. Okay. So let me fix that 4 really quick. So now we're going to start looking here. Beforehand, right? Our divisor was 2 last time, so we just said how many times 2 goes into 2. Well, that was good. But now we actually have a number 12. We're not breaking it down by the 1 digit and the 10 digit. No, we have to take the number as is. So if I'm saying 12, I now have to go in and say, well, how many times can 12 go into 2? And, well, it doesn't. Because the 12 is a lot bigger than the 2. So now we gotta look next door and say, okay, 24 then. Okay, how many times could 12 go into 24? And it actually goes in there perfectly. It goes in there twice. Now, if you're not familiar with your 12 facts, you can just go one of 2 routes. You can kind of write off to the side saying like, oh, 12 times 1 is 12. 12 times 2 is 24. Oh, look at that. Or you can list that out, saying like factors of 12. 12, 24, 36. Either one works, and either one, as long as it helps you out. I will say, once you get to weird answer or weird ways to divide, like we're going to see in the next example, that's going to actually help us out a lot better, especially if we don't have a calculator on our side. Okay. So we know 12 goes into 24 twice, so 12 times 2 is now 24. Now this is where the grid paper helps us. 24. I didn't put 24 starting here. I put it right where it needs to go. So subtract those two. I am getting 0. Bring down my 0 because that's what's left over. 12 can't go into 0, so that's 0. 12 times 0 is 0. 0 minus 0. Now that gives me 0 in the end. So 12 can go into 240 20 times. And if you want, you can always check it. Look at that, it ends up being a 2 by 2 digit right there, huh? And if you would, and by doing that method, you actually end up getting 240 in the end. So good route there. It works, it checks, but I know what you're thinking now. Mr. Wisniewski, it's not always going to be that easy, right? No, because, sometimes it's always funny. I always see online, it's like the problems in math class we go over, like 2 plus 3, the problems that are on the assignment, and then it's like some like really, really advanced math, and then it's like the problems on the test, and then it's like some sort of just weird quantum physics-y, I don't know, just something crazy. So, but at the same time, you need to prepare you for some good old math here. And I'm going to do a different color here. All right, here we go. What do I mean when I have something that's going to be different? Well, I can't help but always think of weird numbers like 17. And we're going to divide that by 574. Oh, sweet goodness, look at that. I mean, I don't even know why I'm being torturing myself this way. But again, some things that we actually may see. So, will we see a remainder in the end? Well, we're about to find out. Remember, I can't I can't do this whole 7 goes into 5 thing. I can't do that. I have to take the number as is. Our number is 17. 17 cannot go into 5. So we have to look to the next part. 17 can go into 57. Now, beforehand, we knew that the other numbers went in perfectly, right? There was a nice round, even whole number that I can, that I'm good with. But we're going to get to this point where it can go into a number a certain amount of times, but it's not going to be perfect. And this is one of those occasions. So remember when I said start kind of jotting off things to the side here? That's going to work. I'm not going to do 17 times 1 because I already know that's 17. So let's try 17 times 2. 2 times 7 is 14. That's 2 and 3, 34. Okay, I think we can do another go up there. 17 times 3. 7 times 3 is 21. Put a 2 up there. 1 times 3 is 3. Plus 2 is, 51. Okay, now, we can stop here because, again, if we do this other method here, doing 17 times 4, we're going to go well over our 57. And just so I can show you visually, here's what it looks like. 17 times 4, that's 28. That's 2. 4, 5, 6. Look at that. 68 is bigger than 57. I can't. If a number doesn't go in perfectly, it's got to be less than the number that we see here. And we know that this is going to be our best route. It can't be this one. And it can't be this one because it's just, again, it's not close enough. It has to be as close to the number that we have here. It can't be extremely less, and it can't go over. Okay, it's got to be kind of like that Goldilocks method, just right in the end, where it's not too low, but not too high. So 51 is going to give us that route. And we said when we multiply that by 3, I'm actually going to put that up here. So 17 times 3, and we already got that in there, is 51. So subtract it. 7 minus 1 is 6. 5 minus 5 is, well, 0. And then I bring down my 4 here. Okay? And as if something amazing just happened, just by having this on the side is going to actually help us out in the end. Now look at this. Now we can just ignore this. And we can look at our 64 only. 17 goes into 64 now. Well, we knew that the next step would have given us 68. 68 is bigger than 64. So we still can't do that. So once again, we're going to have to stick with our 51. So we're going to have to say that's by 3 again. And then 51 goes down here. So then 4 minus 1 is 3. 6 minus 5 is 1. We have a remainder of 13. So remember in the end, we had other examples where this was 0 in the end, so it was fine, but no longer. I actually have a remainder now, and a pretty high remainder of that. So our final answer would be 33 with a remainder of 13. Now, in order to make sure that makes sense, remember, our divisor is 17, right? In the end, when this is all said and done, this number here at the bottom must, and I repeat, must be less than what you're dividing it by. If this number was 18, 19, 20, then this answer would not make sense in the end. Hence why we didn't stick with this guy, the times 2. All right, it logically just cannot make sense. Once again, doing the visual statement, if you're drawing things up, you're dividing them equally, okay? If you drew 17 boxes and you're putting 574 dots in each, box total, you're going to end up with 33 dots overall, but you're going to have 13 left over. Because remember, they had to be equally divided amongst them. It's got to be equal. And it's okay to have remainders. That's absolutely fine. There's nothing wrong with having remainders. It's just, because again, if you would plug this in the calculator, it would say 33 point blah, 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 blah. It's going to have a really weird number in the end. But at least you know it is the correct answer. So again, we looked at more easier dividing multiple digit numbers, and then we looked at this example where it's a little bit more complicated. But once again, the more we practice, the better we can become. So if things like division or multiplication trip you up a lot, I would say even taking out some flashcards, finding some fact fluency games online even to help you out will be even better. Division is always tricky, and I understand. But the more you practice, the better you can get at those, okay? So thank you again. I hope you all are doing fantastic, and I will see you all later on. Have a good day. Bye-bye.